Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer question number 7 from the February-March 2021 Mechanics Paper 4, Variant 2 from the Cambridge A-Level 9709 syllabus. And this question here is a question about these inclined planes. So part A of this question is dealing with basically some dynamics. It says two particles, P and Q, of mass 0.5 and m kilograms respectively, are attached to the ends of a light, inextensible string. The string passes over a fixed smooth pulley, which is attached to the top of two inclined planes. The particles are initially at rest with P on a smooth plane inclined at 30 degrees to the horizontal, and Q on a plane inclined at 45 degrees to the horizontal. The string is taut and the particles can move on lines of greatest slope of the two planes. A force of magnitude 0.8 newtons is applied to P, acting down the plane, causing P to move down the plane as shown in the diagram. So for part A, we're told that m is 0.3 and the plane on which Q rests is smooth. So for part A, we have to, use those values and those assumptions. It says find the tension in the string. Okay, so a few things before we actually go through the question. A lot of students have questions about, which I'm going to try to address now. So two particles, P and Q, of mass 0.5 kilograms and m kilograms respectively, means in that same order, P and Q, 0.5 and m, which is going to be 0.3 for part A, are attached to the ends of a light, inextensible string. So the light part means we ignore the weight of the string, okay, which basically will mean that the tension throughout the string will be the same. So the tension at this point and that point will be the same. The tension at that point will be the same, because there's no like extra weight attached to the string as you go down the string. If it was not light, if the string had a weight itself, then the tension at the bottom of the string would be more than the top, because it has the weight to support of what's above it as well. So that's why the tension is the same all the way through the string if it's a light string. Inextensible means that it doesn't stretch. So basically what that implies is that the acceleration of any particle attached to that same string will have the same magnitude. So this thing is going to accelerate downwards. That's going to accelerate upwards with the same magnitude. Okay. And then, then it says the string passes over a fixed smooth pulley. A smooth pulley means what? It means that there's no friction in the pulley, which basically tells us that the tension on both sides of the pulley in the string will be equal. Okay, so that's what the smooth pulley tells us. And then it says the particles, this is another thing that people have a problem with. It says the string is taut. Okay, taut means the string has tension in it. So there is tension in the string. It's not like loose. So you can have a string that's like loose. You can have a string that's got tension in it. Okay, it's got tension in it. So, it's pulling at each other, right? So you have, when the string is taut, it's got tension in it, okay? And the particles can move on lines of greatest slope of the two planes. So this is another thing. So what does that mean? Well, most of these things that we're talking about now, especially in Cambridge, don't really affect our calculations, or I haven't seen many questions where they ask us to say how they affect our calculations. All right, so it doesn't matter. In this thing as well, most students just ignore what it means if they don't understand it, and it doesn't affect their calculations at the end. But just for your information, imagine we were looking at this, okay, from this angle over here. What we would see in front of us would be some sort of like a ramp. I'm just going to draw in 3D. Some sort of a ramp, and there'll be a string, there'll be a pulley at the top and a string coming over, and you'll have this particle attached to the string. Now, what it means here by the particles can move on lines of greatest slope of the two planes means that basically that it's going to go straight up the slope in this direction. It won't go like at an angle. It's going to take the shortest distance up the slope. That's what that means basically. So those things don't really affect our calculations, but a lot of students don't understand what those things mean. Okay, so now let's get on with the actual question. Now, Just get rid of these highlights first. Okay, so now let's get on to actually answering the question. Okay, so I'm going to draw the forces involved down here so that everything is clear. I'll have to keep scrolling up and down. So two particles, P and Q of mass 0.5 and m kilograms are attached to the ends of the string. So I'm going to draw the forces acting on P and Q. So if we think about P, the forces acting on P would be the weight of P, which acts always vertically downwards. And also, you've got the force pulling it down, which it's already marked. Then you have the tension in the string acting, of course, upwards. Okay. Now remember, this is accelerating down, and this one is accelerating upwards. Okay. There's no friction. There is a reaction force which won't really affect anything in this case because there's no friction here. So that's going to be the reaction force of P, which is always perpendicular to the surface, which the contact is. Okay, so those are the forces acting on this. This is 0.5 G newtons. Okay, in fact, what I'll do is I'll write this as 5 newtons because we know G is going to be 10. So I'm going to write this as 5 newtons. Make this a bit shorter. Okay, so this is going to be 5 newtons. Okay, 5 newtons. Okay, those are the forces acting on P. And on Q, you have its weight, which is going to be mg newtons. In fact, in this case, they've told us m is equal to 0.3. So I'll just put this as 3 newtons. Okay, this is 3 kilograms. 0.3 kilograms, sorry. Okay, 0.3 kilograms. Okay, we have the tension in the string, of course, pulling upwards. So there's a tension here, there's a tension there. They're the same magnitude. Acceleration is the same magnitude. And that's the only force. There's no friction or anything here because this is smooth. This is both smooth, okay, as the question tells us. So those are the forces, apart from, of course, here, the reaction force, which will be acting in this direction, perpendicular to the surface. So what I'm going to do now is I'm going to consider the forces acting on P and Q separately. Now, we always try to resolve the forces in the direction, okay, which is perpendicular and parallel to the motion. Okay, perpendicular and parallel to the motion. So what we're going to do here is we are going to resolve the forces. This force is going to be resolved. This weight is going to be resolved parallel to the slope. And this force is going to be, this is the component of this force perpendicular to the slope. Okay, so I'm going to draw this a bit longer so I can explain something in a minute. Okay, so this is the component of the force. This is a component of this weight, which is parallel to the slope, and this is what's perpendicular to the slope. And the same thing for the 3 newtons. I need to resolve this force parallel to the slope and also perpendicular to the slope. Okay, you always resolve the forces in those directions, always in the direction in which the object would move or would try to move, and always perpendicular to that. So in order for us now to resolve this force, I need to know what this angle is here. Now, what we all, or most students just automatically say this angle is 30 degrees, and that's correct. But some students, they don't know why, and they want to know why. So I'm going to quickly explain why this angle is 30 degrees. And the reason is basically from similarity. These two triangles here are similar triangles. Okay, this angle here is 90 degrees. This angle here is also 90 degrees. They're both 90 degrees. Okay, so this big triangle, okay, now I'm going to actually get rid of this angle here for now. Okay, so that we can understand. So these two angles are 90 degrees. Now this big triangle has these 3 angles, 30 degrees, 90 degrees, and this angle over here. Okay, and this small triangle has 3 angles. This is 90 degrees, and this angle over here, and this angle, which is actually the same angle as in the big triangle. So the big triangle has 90 and this angle. The small triangle has 90 and the same angle. That means the third angle must be the same. So whatever angle this is, this must be the same. So in this case, this is going to be 30 degrees. All right. So that's how we can understand why these two, there's always the angle between the weight and the reaction force, as you extend it, is always going to be the same as the angle of the incline of the plane. Okay, so that's just a little bit extra there for you. I'm just get rid of these now. Okay, so for the same reason as that, this angle here is going to be 45 degrees. Okay, so there's a bit of explanation going into this question. Now I'm going to resolve these forces. Now, when I resolve this 5 Newton force in this direction, it's like basically there's two ways of thinking about it. It's like you want to resolve perpendicular and parallel. So I'll draw a line parallel to the plane here. Now this would be the opposite side, and this would be the adjacent side. The adjacent side is this component I'm looking for. So I would use cosine. So I'll say 5 times cosine 30. And this would be like the parallel to the plane. So this would be the opposite side, which would be 5 times sine 30. Okay? You can also think about it in a bit of a simpler way, which I prefer, is that when you have to resolve, and to resolve, you have to go into the angle given. You have to go into the angle given, you have to use cosine. If you have to resolve in a direction going away from the angle given, you use sine. So this is 5 sine 30, this is 5 cosine 30. So similarly, I'm resolving in this direction going into the angle given, this will be cosine. So this will be 3 cosine 45. And here I'm going away from the angle given, so this will be 3 times sine 45. Okay, so now I have resolved the forces acting on these two particles. So what I'm going to do is I'm going to consider each of those particles separately. Okay, so this is particle P and this is particle Q. It's been hidden by all these diagrams now. So I'm going to look at particle P first and make an equation for particle P. Now for particle P, I'm going to, as it's accelerating down, I'm going to use the fact that the resultant force is equal to the mass times the acceleration. So the resultant force in this case, if I resolve going down the plane, as it's going down the plane, it's moving that way, always resolve in that direction, the direction in which it moves or is trying to move. So you're going to have 5 sine 30 plus 0.8, those are the forces acting down, equals the tension. Minus the tension, not equals. No, it's not equal. It's the resultant force minus the tension is equal to the mass, which is 0.5 times the acceleration, which we don't know. Okay, we were trying to find the tension. We don't know the acceleration as well. Okay, so that's one equation from P. And from Q, I'm going to resolve taking up the plane as positive because it's moving upwards. So if you look at the forces acting on Q in that direction, you're going to have T acting up, and down is only 3 sine 45, so it's minus 3 sine 45 because that's acting down, is equal to mass, which is 0.3 times A. Okay, so those are two equations here, which I can now try to solve. So let me simplify this equation. 5 sine 30 is 2.5. 2.5 plus 0.8 is 3.3. So 3.3 minus T equals 0.5A. And here you have T minus, I'll write this in an exact form. I know that sine 45 is root 2 over 2. So that's going to be 3 times root 2 over 2. Okay. Yep. Equals 0.3A. So these two equations together, I can now try to deal with them. So I'll write this one down here. So I have 3.3 minus T equals 0.5A. Okay, so I'm going to take this equation and multiply it by, because I want to find what the tension is. So if I just add these, the tension will disappear and I'll find A, then I have to find T. I think it's easier in this case to make the A's the same coefficient. So I'll multiply this by 5 and multiply this by 3. Then this will become 5T minus 15 root 2 over 2 equals 1.5A. And this becomes 9.9 minus 3T equals 1.5A. So I've run out of space. I should really have written a bit smaller, but no, I'll just continue over here. Okay, so now, it's going this way now. So now what I'm going to do is I'm going to basically, I can say that I can replace this 1.5A with a 9.9 minus 3T. So I have 5T minus 7.5 root 2, I'll write it like that, is equal to 9.9 minus 3t. So I can bring the t's together. 5t plus 3t is 8t equals 9.9 plus 7.5 root 2. So t is going to be 9.9 plus 7.5 root 2 all over 8. So that should give me the correct answer. Let's see what happens here. We're going to have 9.9 plus 7.5 times root 2 over 8, which gives me 2.5633, 2.5633, which of course we have to write to 3SF, so 2.56 newtons, and there is our answer for question 7 part A. Okay, now 7 part B is actually work, energy, and power. And as I'm trying to save my questions according to question as well as topic, what I'm going to do is I'm going to save 7 part B in a separate video so that I can put that as, I can include that in the work, energy, and power playlists, and this will be in the dynamics playlists. And then when I'll also save them together under the same playlist for this particular paper. So, you'll find them in the playlist for this paper, both together, and you find them according to the topics in separate playlists. So I'm going to stop this video now, and I'll make a new video for part B. So for this particular video, if you'd like to find other questions, including part B of this, question, you can go to the playlist that will appear over here. Okay. You can watch other questions dealing with dynamics from Cambridge by clicking on this link over here. I will also include a link here to dynamics that are included in connected particles and dynamics from my Edexcel collection, because there's a lot more questions in my Edexcel collection, and they're very similar. The only difference is using G as 9.8 instead of 10 in Edexcel. That's all. And I'm going to also put a link here to the actual part B of this question. Okay, so you can link from there to the next part of the question if you need to. Thank you for watching, and see you soon.